So in today's class, we have to start with this derivation of this formula NPR and NCR. NPR is out of n distinct objects arrangement, that is permutation of R objects, and then we will go for this combination part. So forget right, don't think about the combination right now, we'll just think about the permutation. So what type of examples I will give you? I will directly give the example. Let's say question number 1. Do you remember that in your childhood, means everybody must have done this question, this puzzle, everybody must have faced this situation in your childhood. We used to have that suitcase, we used to have, and in that suitcase a numerical lock will be there, 3-digit numerical lock. And sometimes when we used to forget the suitcase lock, means if the mummy or papa, anyone forgets the suitcase lock, they used to tell us that open the suitcase, and it used to be fun to us. That suppose let's say for example, hypothetically, if the password, the suitcase lock, the code is, let's say, 249. So we do not know, we do not remember as child. Only the parents used to know. So what we used to do to open the lock of the suitcase? We used to set all the 3 counters to 0, 0, 0. Correct? Then we used to pull that lock and see whether it opens. No, sir, it does not open. Then we used to change this last counter to 0, 0, 1. We used to again pull the suitcase and let's see whether the lock opens. No, sir, it is still not opening. Then we used to change the counter to 0, 0, 2. Sir, it is still not opening. 0, 0, 3. We used to still not opening. Then up till when we reach 009, so it is still not opening. Then we used to change this another counter, 0, 1. Now once you fixed this part, 0, 1, then again we used to again repeat the exercise, 0, 1. So with 0 we will go on changing, it is still not opening. Then with 1 we will try to open the suitcase, it is still not opening. With 2 we will try to open the suitcase, it is still not opening, and so on up to 9. So it is still not opening, and so on. Has everybody faced this situation sometimes in their life?
Yes, sir.
Okay. So that is a question of permutation only. So I can give you, let's say, at what attempt will you be able to open this suitcase? So 249 is a small number, or let's say if the password would have been hypothetically, let's say 0, 1, 0. In the 11th attempt only you would have opened the suitcase. The first attempt is 0, 0, 0. In the 11th attempt only you would have opened the suitcase. Or let's say if the password would have, or even if I give you this question, how many different passwords are possible for this suitcase where this 3-digit numerical lock is there? How many different codes are possible? So you do not have to solve this question. I'm just giving an example. So this type of questions we will be dealing in today's class. In today's class, we will be dealing with these type of questions. Okay, so let's start with the basic one. Question number 1. Step by step, I will go on increasing the difficulty, and when needed, I will give you the formula. If I directly give you the formula, you will not realize the derivation of that formula. I want you to think 1 or 2 questions. You will think yourself. After that, I will give you the formula. Okay. So first question is, in how many ways can you arrange 3 letters yes? In how many ways can you arrange 3 letters yes? Think over it and write your answer in the chat box. Yes, correct, Yash. No, Dhananjay wrong. Kartikeya correct. Shreya Rahul wrong. Dhananjay, your first answer was right. Second answer you gave wrong. Okay, see, the correct answer is 6. So in how many ways can you arrange 3 letters? Yes. So what is the arrangement? Let's say, sir, 3 places I have to fix. First position, second position, third position I have to fix. Now this suitcase problem, when you used to solve as a child, we were not even aware that we are solving the question of permutations. This suitcase problem, when we used to solve, now suppose there is one suitcase you are opening and another suitcase your brother is opening, your brother or let's say your sister. Okay, both of you have different approaches. You are doing the approach, sir. First I will start with 000, then with 001, then with 002, till I will finish till 9. Then 010, then 011, then 012, I will finish till 9. Then 02, 01234, and so on. And your brother or your sister, or let's say your friend, anybody, he is doing, let's say, sir, I like the number 101, I will try with 10. No, sir, it's not opening. Then, sir, let's say my another favorite number is 125. I will try with 125. Sir, it's still not opening. Okay. So then I got to know that my another favorite number is, let's say, 725. Sir, it is still not opening. And he's just choosing those random numbers and trying to open. So who do you think has a better approach? Who do you think has a better approach, a better chance to arrive at the password? Obviously your approach is better. It's a more systematic approach. So counting, arriving at the answer is not important. At how you approach the question, how you count, that counting process is important. If you go on counting randomly like your brother did, it will take a lot of time, and lot of time means the questions that we want to solve, we will not arrive at the answer. So here, pay attention to the thought process, pay attention to the way in which we got the answer. So 3 letters have to be arranged. So what I will do is, so first position, let's say it is fixed y. Every time at first position it is y only. Now the second and third position, what I can do? So second and third position, I can either do E, S, or I can do S, E. So there are 2 approaches. That's it. Sir, now y with first position fixed as y, there are no more arrangements. These are the only 2 arrangements. Okay, sir. So now let me change the first position. First position y is fixed. Now I will not put at the first position. Now I will not put y, except y anything, because with y at the first place everything has been covered, has been counted for. Now let me put E at the first position. So these are totally different arrangements. So since these are totally different arrangements, now what are the different the countings possible? The countings possible is again y and s and y. So again 2. Okay, and after that S at the first position, and Y and E, and let's say E and Y, and here it will be 2. So total, can you see that it is equal to 6 arrangements? Okay, so this is 2 plus 2 plus 2. The final answer is 2 plus 2 plus 2. Means that Y at the first position there are 2 arrangements, E at the first position 2 arrangements, S at the first position 2 arrangements. So total 2 plus 2 plus 2, that is 3 into 2 arrangements. Okay, I will write it as 3 multiplied by 2. Unitary method. First position 2 At first position, if y is there are two arrangements. So at first position, how many letters can occur? 3 letters can occur. So 3 multiplied by 2. Okay. Now instead of this YES, if I would have given you THE, same answer would have been occurred. It's a very obvious question. In how many ways can you arrange the 3 letters? THE, no change. Okay. So just keep that in mind. I will use this fact afterwards. Now let's move one step ahead. Question number 2. Number of permutations of the letters of the word FOUR, 4, is equals to how much? Number of permutations of the letters of the word 4 is how much? After permutation is only going on.
Okay, sir. Sir, could you just scroll down, sir? I haven't yet to copy the first question.
Okay.
1 minute.
Yes, Kartikeya correct. Yash correct. Uvi wrong. Dev correct. Pujita wrong. And Kartikeya is also correct. Okay, so those who have got the answers correct, Yash, Dev, and Kartikeya, think what will be the answer if it is a 10-letter word. Those who have got correct answers, Yash, Dev, Kartikeya. If it is a 10-letter word, okay. Dhananjay, your answer is wrong. Yes, correct, Kartikeya. Very good. Yes, Yash also correct. Aditya, your answer is wrong, Aditya. I don't know for which question you're answering. For both the questions, your answer is wrong. Okay, Aditya. Okay, see students, permutations of the letters of the word for. Now I will use the previous question number 1 to answer this question. Okay, now these questions were step by step increasing the difficulty level. So for this question, what I will do is, let's say S4, number of ways. Let me represent this by S4 is equals to number of ways of arranging, or you can say number of permutations, number of ways of arranging 4 letters of the word F-O-U-R. Okay, so S3 will be now with this notation S3. S3 will be what? Number of ways of arranging 3 letters, and 3 letters will be given. Number of will be given 2 letters. S2 will be number of ways of arranging 2 letters. Okay, so just cancel this part. Now, so now S4 is what, sir? S4, if I want to tell you, sir, if I give you S4, if I now 4 positions you have to fix: first position, second position, third position, and fourth position. Now, what I'm telling right now, does this make sense to you, sir? If I fix F at the first position, F is fixed at the first position. So OUR in whatever ways they can be arranged, I don't know right now. OUR, they are remaining in whatever ways they can be arranged. Let's say they can be arranged in 100 ways, hypothetically. S3 number of ways, S3 number of ways, OUR. Let's say that figure S3 equal to 100, hypothetical. They can be arranged in 100 number of ways. So if F is at the first position, the number of remaining arrangements is S3, or let's say 100, hypothetically. So instead of F, if I fixed O at the first position, now what letters will be remaining? What letters will be remaining will be F, U, R, and they will again be arranged in 100 ways only. Let's say S3 number of ways. It won't change, no? Like the example I gave you. If you arrange YES or you arrange THE, what difference does it make? It's a very obvious statement. Okay. So if F is arranged at the first position, whatever arrangements you're getting, the same number of arrangements you will get if you arrange O at the first position, U at the first position, or R at the first position. Okay. So let's S4. S4 is the total number of arrangements. Sir, if I place F at the first position, if I place F at the first position, what is the total number of arrangements? Is it equal to S3? Do you agree with me?
Yes, sir.
F is fixed at the first position. The total number of arrangements is S3, the remaining 3 letters. If I place F at O at the first position, again it is S3. U at the first position, again it is S3. R at the first position, again it is S3. So for one fixed letter, the arrangement is S3. But here I have 4 choices at the, so it will be 4 multiplied by S3. Is this statement clear to everyone? Do everybody agree with this statement? If you understand this part, then we can proceed ahead. If this part is not clear, you will not understand anything.
Sir, I didn't understand this, sir.
Means now here I'm using unitary method. 1 mango costs 10 rupees, 7 mangoes, how much? So that is F at the first position, there are S3 arrangements. O at the first position, F at the first position, S3 arrangements. O at the first position, S3 different arrangements. U at the first position, the remaining 3 can be placed again in S3 different ways. R at the first position, the remaining 3 letters. The remaining 3 letters again in S3 different ways. So total number of arrangements is addition of all these. S3 plus S3 plus S3 plus S3. How much? 4 multiplied by S3.
Yes, sir.
Right now we do not know the value of
Yes,
S3,
sir.
correct? So
Yes,
now
sir.
our target is to, sir, S4 is equals to 4 multiplied by S3. So now my target is, sir, F I have already used up. I want to find this S3. What is the value of this S3? So F, how did we obtain S3? Sir, F we have already fixed. Okay. Keep this in mind that F has already been occupied at the first position. Now we cannot change that. Now I have been only been left with O, U and R. That's it. O, U and R, that's it I have been left with. So with O, U and R, now the question reduces to the same question, but a smaller one. The smaller brother of this. Number of permutations of the letters of the word O, U and R. So O, U and R, what can be there? So three positions are there. In these 3 positions, 1, 2 and 3. Here I put it. Let me highlight this thing. Now to calculate S3, so for S3, 3 positions are there: O, U and R. Again, we will repeat the logic. The counting logic will go on repeating. So O at the first position, if it is fixed, how many arrangements are there? S2 arrangements are there, the remaining two letters? Yes or no? If U at the first position, again S2, R at the
Yes, sir.
first position, again S2. So total how many will be there? So 4, it is already there. 4 multiplied by this S3. S3, what is this S3? S3 is 3 multiplied by S2. Do you get this? So S3 will be equal to, let me just write it first. S3 will be equal to 3 multiplied by S2. Again, do you agree with me? Same logic, unitary method. First position, S2 arrangement. So first position, there can be 3 possible ways. U, O, U and R. So 3 into S2. And S2 is what? S2 either you can again repeat it. So 2 values are there. S2 you can write equal to, directly you can write 2 also. So S2 only 2 letters are there. U and R. So U and R or R and U. Either U R or it is RU. So you can just directly write 2, or you can extend the idea, sir, S2 will be equal to 2 multiplied by S1. And now only one letter is left. Only one letter is left. In how many ways you can arrange it? You can be arranged in one way only. So now just go on substituting in our original formula. S4 is equals to 4 into S3. So S4 will be equal to 4 multiplied by, sir, S3 is what? S3 is 3 multiplied by S2. 4 into S3. Sir, S3 is nothing but 3 multiplied by S2. But S2 is
We
2
can
multiplied.
directly write it as 4 into 3 into 2 into 1.
Yeah, this is, I'm explaining this first part. That's why I'm doing it in so much detail. Next,
Okay, sir.
we will not do in so much detail. So S4 will be equal to 4 factor. Do you get this thing? Okay.
Yes.
So can you, so this is something like, so first, second, third, fourth. At the first position, actually there are 4 choices. First position, there are 4 choices. At the second position, so second position, there are 3 choices. Why there are 3 choices? Because of one letter has already been occupied. Here the condition that is 4, 3, 2, 1, the condition that is important here is, that is the hidden condition which is there is without repetition. Without repetition means it is not, we are not considering the case now where F and F can be repeated. F, 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 F. We are not counting that. Or F, F, U, R. We are not taking those possibilities. Without repetition, just simple, you have one F, one O, one U, and one R. That's it. So if 4 choices are there at the first position, at the second position, you are left with 3 choices. At the third position, you are then left with 2 choices only. And at the last position, you are left with 1 choice only. So we use the multiplication principle. Multiplication principle is 4 into 3 into 2 into 1. And so why we are using multiplication principle? Actually, the book gives the reason that these 4, 3, 2, 1, they are dependent. But don't fall for that. Just say it's a simple unitary method. I like this approach. 4 into 3 into 2 into 1, 4 factor. That's it. Okay. So now, if I extend the same idea, and I give you this statement, generalized result, number of ways of arranging n distinct, okay, distinct word is very, very important. Underline it. I will give you examples when some of them are not distinct. And distinct objects. Number of ways of arranging and distinct objects is equal to Can you say the statement n factorial? Will everybody agree with me?
Yes, sir.
Okay.
Yes.
So this is the one result. This is the first result for today. It will be n factorial. Now out of this, this was question number 2. Questions we have done, right? Yes, so now if you have this straightforward formula, be sure that in your JE exams or even in your board exams, nobody will ask you the straightforward questions like 4 objects are there and four distinct objects are there, and how many ways can you arrange them? Okay, number of ways of arranging n distinct objects is equals to n factorial, and you can say in n places, in n places, and also write without repetition. The things that I've underlined, you underline them. Okay, now a number of ways of arranging n distinct objects in n places without repetition is equals to n factorial. And the same question with repetition also, let's give the suitcase problem. With repetition, what happens? The same question now, let's say here, the FOUR only you take. Number of permutations of the letters of the word FOUR is. Question number 3 I will give you. How many 4-letter words? How many 4-letter words can be formed out of the letters of the word four, FOUR, with repetition allowed? Now this time I am telling you that repetition is allowed. Thank you. The hint diagram, always try to understand mathematics pictorially. So picture is this is the picture where my cursor is. This picture is the hint. Yes, correct, Karthik. Pujita wrong. Dave, that 10 letters that I have given you the previous question, you do not need to calculate the 50,400. I don't think 50,400 will be right, because yesterday only we calculated 8 factorial to be equal to 36,000 something. You could have just written the answer as 10 factorial, Dave.
Yes, sir.
Okay. If you're getting big numbers, you can just write the answer as 10 factorial. That's it. No need to calculate the value. Yesterday we had done this discussion. And 10 factorial is not 50,000 something. 8 factorial was only 36,000. Yes, Puvi, right? Kartikeya is correct, Puvi is correct, Pujita wrong, Yash wrong, Pujita still wrong, Dhananjay wrong. Okay, no problem, Sriridhi. The part that you have missed, go through the recording, Sriridhi. This is the suitcase problem. This question is the repetition of the suitcase problem. Afrin, only 3. No Afrin.
Sir, could you explain this, sir?
Okay, see. 1, 2, 3, 4. Okay, 4 places are there. And we have 4 letters, F, O, U, R, but this time repetition is allowed. Means I can start with F. Again, I can go with F. At the 3rd place, also I can go with F. At the 4th place, also I can go with F.
But then it will be 4.
But this is one arrangement. This is one arrangement. F, 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 F. Got it? If I just change this to, let's say this is F, 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 and let's say O. This is second arrangement after. This is not means the one that I've written ahead. F, F, F. That is not 4. That is first arrangement. Triple F, O. This is second arrangement. And so on and so on and so on. So how much? How many such arrangements are possible? So this is the suitcase approach like that. In suitcase, what we used to have in suitcase, we used to have the repetition 0, 0, 0. And here also the possibilities are from 0, 1, 2, 3, 4, 9. At the second position also, the possibilities are from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These two are nowhere related to each other. If it can be here 9. At the third position also there can be 9. At the second position 9. At the third position it can be 8. No relation. It's completely free of each other. Here at the first position also 0, 1, 2, 3, 4, 5, 6, and 9. So exactly same problem has been repeated, but with letters. With letters, how? First position, second position, third position, fourth position. So actually, this is something like, so 4 positions are there. 1, 2, 3, 4. 4 positions are there. At the first position, it can be F, it can be O, it can be U, it can be R. So there are 4 choices. At the second position, sir, again it can be F. Don't think that here F is there, so at the second position F cannot occur. Again it can be F, it can be U, it can be F, O, U, R. So again it can be 4 choices. Third position, again can I say 4 choices. Fourth position, again it can be 4 choices. So how to count now? So you can say that it will be equal to 4 into 4 into 4 into 4. So why are you doing multiplication? I'm doing multiplication. I'm just in my mind, I'm doing the unitary method. At the first position, let's say if I fixed F, again, see how we counted this approach. If I go for the F, if I fixed F, then the remaining approach is S3. If I fixed F, for now my target is for S3. If I fixed S3, so one F is fixed, so S3, second S3, third S3. So how many totals? At the first position 4 can occur, so 4 into S3. So similarly here I am doing at the first position, whatever is the letter, if one letter is fixed, whatever the number of arrangements are there, and now forget about the letters S3 and all those things. First position, what if one letter is fixed, whatever arrangements are there. If second letter is fixed, the same number of arrangements will occur. So at the first position, one arrangement, so what, one letter, so whatever arrangements. So at the first position, 4 letters multiplied by remaining arrangements. Okay, so now my target is the remaining arrangement. So forget about the first position. Concentrate on the three remaining positions. If I fixed one letter, whatever is the remaining arrangements are there. If I fix second letter, the same letter will be there. So FOUR. So at the second position, again 4 possibilities are there. So 4 at the third position, again 4 at the fourth position, again 4. Do you understand this explanation? 4 into 4 into 4 into 4. So this will be equal to, this is not 4 factorial, this is 4 to the power 4, or you can say this to be equal to 256. Everybody got it? Okay.
Yes, sir.
How many five-digit numbers are possible using the digits 4, 6, 7, 8, 9, with repetition allowed? B part, without repetition. For the fourth A part, I'm giving you two options. Now for B part also, two options are there. 4 raised to 5, 5 raised to 4, 4 factorial, 5 factorial. In the chat box, you can either use the exclamation mark also. Of a factorial, you can write simply F. If your answer is 4 factorial, you can simply write 4F. Okay. These are your options for both the questions, A part and B part. Now 1 minute. And another is 4 to the power 4, and another option is 5 to the power 5.
Sir, for A1, it is 4, like
Type. Yes, Dave, correct both A and B. Dhananjay, you have calculated. Don't calculate. Don't calculate. Yes, Dhananjay, A part is correct and B part is wrong, Dhananjay. No need to calculate the values. If you're giving values by calculating, don't. A part is wrong, B part is also wrong. Dhananjay, A part is right and B part is wrong, Dhananjay. Afreen, both the answers are wrong. Yash, second is right. And first I'm assuming that P stands for power. Yash, the thing that you have written. Is it power?
Yes, sir.
Okay, the answer is wrong, Yash. First one answer is wrong. Dhananjay still second is still wrong, Dhananjay. Preen first is wrong. Shreya Rahul first correct. And second is wrong, Shreya Rahul. Puvi, yes, now your both the answers are correct, Puvi. Shreya second is correct. Okay, see everyone now. With repetition allowed. So in my mind, whenever such question comes, I picturize it in this format. How many places are there? How many 5-digit numbers? Okay, 5-digit numbers. I think like this: 1, 2, 3, 4, 5. I always think in the terms of that suitcase only. How many 5-digit numbers are there? 5-digit numbers, 5 positions are there. Okay, are possible using the digits 4, 6, 7, 8, 9. Okay. Now A part I am solving. Okay, A part I am solving with repetition allowed. So with repetition allowed means what? This suitcase is there in front of me, and in behind this suitcase, the with repetition allowed means at this first position 4, 6, 7, 8, 9. This what to say, that scroll that is there no, in the suitcase, that mechanism that is fitted 4, 6, 7, 8, 9. We can turn it and scroll, put the and get the digit whatever we want on the front side. 4, 6, 7, 8, 9. And all these individual numbers, all these numbers are independent. First position number, second position number, third position number, fourth position number, they are all independent. Means 4, 6, 7, 8, 9. First position, if 4 is there, the second position 4 can occur. Nobody is stopping. So I just have to, using my fingers, I have to scroll these numbers. Any number you can bring on the top. Scroll these numbers, any number you can bring on the top. So what I see here I see there are 5 choices. Here again 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 there are 5 choices. So the answer is 5 to the power 5 with repetition allowed. Okay. A part with repetition. And the B part without repetition. Without repetition is something like this only: first, second, third, fourth, fifth. As soon as at the first position there are 5 digits, 5 choices. But since repetition is not allowed, as soon as I fixed the first number here, first digit here, at the second place I am left with 4 choices only, 4 digits only. I do not have any other choice. At the third position, I have been left with 3 choices only, 3 digits only. Then 2 digits only, 2 choices only, and lastly 1 choice only. So it will be 5 into 4 into 3 into 2 into 1. 5 into 4 into 3 into 2 into 1, which is 5 factorial. Okay. Afrin, you typed 5 to the power 4 here. That's why I said wrong. Okay. If you have written 5 to the power 5, then it's correct. Okay. Now I will step up the level one more. We'll go to another level now. Question number 5. 0 creates a problem in these type of questions. Okay. 0 creates a problem in these type of questions. Now here actually our life is being very simple. I'm giving you 5 digits and I'm giving you to fill them up in 5 places only. The formula that I have given you, number of ways of arranging n, 1 minute after, number of ways of arranging n distinct objects, okay, in n places and without repetition. 3 words I have underlined in red. Now repetition part that we have dealt with. Repetition part, how we have dealt with how to deal with the repetition. So this red underline, you know how to solve the variations of this question. Without repetition, with repetition, that variations we have done. Now what is this n places? And now distinct part, we will go to that part at the last. If the objects are repeated, if some objects are alike, like say here the digits that I've given you, 4, 6, 7, 6 and 9. 2 digits are repeated and others are distinct. So we will deal with those questions at the last stage. And now this n places. So what is the meaning of this? So with n objects and n places, life is simple. Means when I'm telling you to fill up, your digits are getting emptied. You're not having anything left with you. If I give you 10 digits and 5 places, or 10 digits and 4 places to fill up, life becomes a little bit more complicated. That questions we will deal with afterward. Means today's class only after one question maybe. After this question, I will give you that question. We will go to that part. Okay, Afrin, you were saying something. What is your doubt?
Sir, I was saying when you were doing this suitcase, that explanation, sir, I wasn't there, sir.
Suitcase explanation I only gave. I did not answer the question what is the suitcase explanation. I only told this how to, means when we used to open the suitcase, that problem, that it is just a repetition of this. I'm giving you again. I did not give much explanation on the first part. That
Yes,
much
sir,
you can
this
say
first
correct.
question also I wasn't there, sir.
So please go through the recordings of the first question. Now I cannot go.
Okay,
The
sir.
students are waiting. No. Okay. How many four-digit numbers are possible using the digits 1, 3, 5, 7, 9? With repetition allowed. The options are 4 to the power 5, 5 to the power 4, 4 factorial, 5 factorial, 4 to the power 4, and 5 to the power 5. Option A, option B, option C, option D, option E, and option F. Here, this question can be done, but it means we have done this type of question. This question is well within your scope. The only thing is sometimes students commit a silly mistake here. 4-digit numbers are there and you have 5 places, 5 digits with you. Shreya Rahul correct, Yash correct, Uvi wrong. Same mistake I was expecting. The mistake that I am expecting, the silly mistake. Matlab silly mistake, I can either you can say silly mistake. Actually, not a silly mistake, it's a confusion. So Uvi has got confused. Uvi has committed that mistake. Shreya and Yash, they have answered it correctly, but I can still be, because I cannot see your faces, so I don't know your confidence over this, your answer. Okay. Pujita, okay, now you have given in options. Let me see the options order. Pujita wrong, Dev wrong, Afreen wrong. Dev also has committed that same silly mistake. Pujita also that same silly mistake. But it's not a silly mistake, confusion. Pujita, you're not, I don't trust your answer now. It is right, but it's a 50-50% probability. The answer. Afreen, okay, confused answer. Wrong, it is Afreen. Dhananjay, now your answer is right. Others think. Many students are not answering only up till now. I have not received one, not even one answer from them. Janvi, Niranjan, Shikhar, Akshay, Akash, Aditya. SO1 students, please answer. Only some of you are answering. Sriridhi.
So I have a doubt, sir. So I didn't do it. First, I didn't attend the class, sir. So I have a doubt to do it.
Okay, fine. See, how many 4-digit numbers are possible using the digits this? So 4-digit numbers. 4-digit numbers so have 4 positions. 1, 2, 3, 4. And what is saying with repetition allowed? Okay, fine. Repetition is allowed. 4 digits are there. Now, what digits has he given me? 1, 3, 5, 7, 9. So at the first position, behind that lock, I have 1, 3, 5, 7, 9. So there are 5 choices. Yes or no? At the second position, since repetition is allowed, I again have 1, 3, 5, 7, 9. So there are 5 choices. Third position, again 5 choices. Fourth position, again 5 choices. So what is the total number of arrangements that I can do? 5 into 5 into 5 into 5, not 4 into 4 into 4 into 4. I was expecting the confusion between option A and option B. 4 raised to 5 or 5 raised to 4. That is the confusion. And the answer, if you go with this picturization, then you will get the answer that it is 5, 5, 5, 5. So 5 into 5 into 5 into 5. So this is 5 to the power 4. This is the correct answer. Okay.
Yes, sir.
Now we will go on to the next level, the question of NPR. Now in this question only, how many 4-digit numbers are possible using the digits 1, 3, 5, 7, 9 without repetition? Now we are getting in the world of NPR, the symbol. Take this as a star question because here we will be using the symbol. Actually, don't refer the NCERT right now. Right now for this question, don't use the formula. Think you can solve this question by yourself only. Okay, this is the star question. Or let's say how many 5-digit numbers are possible out of the digits 1, 2, 3, 6, 7, 8, 9. How many digits are there? 1, 2, 3, 4, 5, 6, 7. Yes, 7 digits I have given you. Okay. And consider, let's say 4 also. 1, 2, 3, 4, 6, 7, 8, 9. Okay. So total, how many digits are there? Total I have given you 1, 2, 3, 4, 5, 6, 7, 8. 8 choices. Okay. 8 choices I have given you. How many? Don't answer. 1 minute. I have not finished the question. How many 5-digit numbers are possible out of the digits, out of these 8 choices without repetition? Okay. Without repetition. This is very, very important. And in all these questions that I have done, all these questions, from question number 1 to question number 5 and this star question, remember that nowhere I have included the digit 0. That digit 0 I have nowhere included, because that creates a different case. You can write that in margin. In your margin, you can write it down that 0 problems, 0 digit not included. 0 digits questions, slight variation is there, a slight variation, nothing much. So just write down that small note in the margin. Think for a while over this question. No need to give the answer in the numerical form, like say 5,000 and something or 3,000 and something. You can give your answers like this also. Let's say, sir, a factorial plus 5 factorial divided by 2 factorial, or maybe if you want to give it in the chat box, you can write this as 8f plus 5f divided by 2f. Or you can, this is just a hypothetical I'm doing, okay, randomly I'm writing anything. Or if you want, if you feel that, sir, this is 8f multiplied by 5f complete square or complete under root, anything like that. Even if that instead of 8 and 5, if you want to use 13, 11, 10f, anything, it's your choice. Okay. Yes, Yash, very good. Pujita, wrong. Both the answers are wrong, Pujita. Puvi, wrong. Dhananjay. Dhananjay, wrong. Dhananjay, you write here. You can write 8 factorial, finish it. Why are you giving the explanation? Okay, it's wrong, Dhananjay. Kartikeya. Yes, Kartikeya, correct. But Kartikeya, have you thought over the process? Means I'm rather than the final answer, I'm more interested in how you think, how you count. Like in the suitcase I gave you, you and your brother is counting. One is the systematic approach and one is the trial and error. Means if you go by the random approach. So I'm more interested in how you count, how you think. So your answer is correct, but let's hope that you have counted it properly without using the formula. Okay, Shreya, your also answer is correct, but again I hope that you're solving it without using the formula. Blind application of the formula is a dangerous situation. Afrin, wrong. Dev, correct. Others, I will draw the diagram, hint diagram. What he is telling you, 5 digits. So now we have stepped up in this variation. N distinct objects, and instead of n places, we have some different number of places. Okay, some different places we have. Let's say lesser number of places. Okay, this n they can vary now. Out of this n places, we can have, let's say, less than n number of places also. And so 5-digit numbers. 5-digit numbers are there. So 1, 2, 3, 4, 5. 5-digit numbers are there. First position, second position, third position, fourth position, fifth position. And what he's telling, so without repetition is asking. Without repetition is asking at the first position. First position, how many? What are the possible digits? The possible digits are 1, 2, 3, 4, 6, 7, 8, 9. So total at the first position. At the first position, total there are 8 choices. Can you see? At the first position, there are 8 choices out of those 8 digits. Now, since we are using without repetition, once you fix any of the digit here, at the second position, you are left with 7 choices only. Do you realize this part? Not many questions we have done. At the third position, you are left with 6 choices only. At the fourth position, you are left with 5 choices only. And at the fifth position, you are left with 4 choices. Means this is the question, the first question of today's class. First question of today's class. So at the first position, S4 is the total number of arrangements. So 4 multiplied by S3. Then we've concentrated on S3. That 3 multiplied by S2. Lastly, we were left with 1. Okay, fine. So we went to 4 into 3 into 2 into 1. In the question that we are doing now, we are starting with 8 multiplied by another number, 8 multiplied by the remaining arrangement, and that remaining arrangement is 7 multiplied by the further remaining arrangement. That further remaining arrangement is 6 multiplied by remaining, and this further remaining is that lastly it is not, we are not going up to 1. Lastly, whatever that number is, lastly if it is 5 remaining or 6 remaining, we will stop at 6. Okay, fine. So what is the problem? Last arrangement, if it is 5 or 6. So why should we have a problem with that? It is not a compulsion that we should go up to 1. So that same argument, that same thought process we have used over here. So 8 into 7 into 6 into 5 into 4. We have stopped at 4. Okay, fine. So the number of ways, 8 into 7 into 6 into 5 into 4. That's it. So this will be the choice. 8 into 7 into 6 into 5 into 4. Everybody got it? I will give you the formula afterwards. Right now, just write it down this way. Without the formula, this is the answer. Now, don't bother calculating it. This is the answer. Okay? Don't bother calculating it. That is a clerical work to calculate it. 87654. Now, out of this generalized result. Okay, generalized result. Out of n distinct objects, repetitions will go afterwards. Out of n distinct objects, number of ways of arranging R objects. So total n objects are there, number of ways of arranging R objects without repetition. And what is this R? Where R is definitely less than or equal to n and greater than or equal to 0, obviously. We are always dealing in integers only, okay? Positive integers or natural numbers or whole numbers, you can say. Okay. So, sir, out of n distinct objects, number of ways of arranging R objects without repetition. So let's means number of objects is greater. Okay, keep this in mind. You have to fill up R places. R places you have to fill up. This is first position, second position, third position. This is first position, second position, third position, fourth, fifth, sixth, fourth, fifth, sixth, so on and so on and so on. Lastly, this is the rth position. Rth position. Before that, it is r minus 1th position. R minus 1th position. Okay, these all we have to fill up. So at the first position, what are the number of choices? Can you see that there are n choices? Everybody. At the first position, there are n choices. Okay, and n is greater than or equal to n. This same question. Now I'm just telling in terms of generalization. Out of 8 digits, we have to fill up 5 places. So at the first position, n choices. At the second position, there are n minus 1 choices. Third position, there are n minus 2 choices. so on and so on and so on. Now this is a little bit application of geometry, arithmetic progression also, progressions. They are going on decreasing by 1, 1, 1, 1, 1, 1, 1, 1, 1, n minus 1, minus 1, minus 1, up to the rth term. What will be the rth term? Think of it in this way. First, addition 1, addition 1, addition 1. SO2 and SO3 students will know this. Plus 1, plus 1, plus 1. This is n minus 1, minus 1, minus 1. So this addition remains constant. This addition n plus 1. This addition is again what? N minus 1 plus 2 is n plus 1. This addition is what? N minus 2 plus 3, it is n plus 1. Everywhere the addition is coming n plus 1. This is an increasing AP, this is a decreasing AP. So here the last position, you have to just find the rth term of this rth term here of this AP. N minus 1, n minus 2, and so on. What will be the rth term? Rth term will be n minus r minus 1 in bracket. So how did you arrive at this conclusion? N minus r minus 1 in bracket. So I thought of it in this way. First of all, if I just ask you given very simple question, what is the total number of numbers? How many numbers of what is the total number of natural numbers from 9 to 15? What is the total number of numbers, natural numbers from 9 to 15? The answer is not 6. Count it. The answer is not 6. The answer is 6 plus 1. Count it on your fingers. 9, 10, 11, 12, 13, 14, 15. There are 7 numbers are there. Okay. So 6 plus 1. You have to subtract it and add 1 to it. So if I tell you what is the total number of numbers from 1 to 15, 1 to 15 you can count it as that's 1 to 15, it is 14 plus 1, so the answer is 15. Yes sir. Means what do? We do sir 15 minus 9 here, addition 1. Here we do 15 minus 1, addition 1. For that from, and for that between we have to subtract it. But if I give you from 0 to 1, from 0 to 15, so what will be the answer? 15 minus 0. So this is the number of natural numbers 1 to 15. 15 minus 0, and you have to include, we have to add plus 1 because you have to add that 0 also. So the answer is 16. Does this make sense? Actually, this is not the, you should know this in their school levels only. Okay, so here actually it was n minus 0, minus 1, minus 2, and so on. So n minus what? So 0, 1, 2, 3 from this 0 subtraction, 0, subtraction 1, subtraction 2, and so on up to go for rth place. So rth place, if I want to go, if you think that's a lastly I will do r, n minus r. So you have counted r plus 1 positions, 0, 1, 2, 3. From 0 to r, how many numbers you have included? You have included r plus 1 numbers. So I don't want r plus 1 numbers. I want r numbers. So I will subtract r minus 1. Is the explanation clear? How I arrived at this lastly n minus r minus 1?
Yes, sir.
Everybody? Okay.
Yes, sir.
Now you can just think that you have to find the rth term of this AP, but that will be just you are escaping the thought process. Don't escape from the problem. Okay, so n minus 1, n minus 2 up to n minus in bracket r minus 1. So this is same as n minus 1, n minus 2, then there will be n minus 3. The integers are going on decreasing, like 8 into 7 into 6 into 5 into 4. The integers are going on decreasing up to what? It is going on decreasing up to n minus r plus 1. Here it will be n minus r plus 2. From left to right it is decreasing, from right to left it is increasing. Okay, so total there are r positions. This is one position, this is so the final answer is n, this is all in multiplications, So n into n minus 1 into n minus 2 into n minus 3 and so on and so on up to the last integer that we have. We have to stop our process at n minus r plus 1. So this is so complicated to remember. Yes, I know it is a little bit complicated. So this is something like we have started with n8 and we have stopped at the by taking 5 integers 8 7 6 5 4. We have stopped at 4. 5 integers we have stopped at 4. Okay, so 5 integers. So here are integers we have taken. So n minus 0 0 1 2, there is subtraction 0 subtraction 1 subtraction 2 subtraction r minus 1. So 0 to r minus 1 r. Yes, 0 to r minus 1, there are r integers. Yes sir, r brackets are there. Okay, so r brackets we have stopped. Okay, so we have now we will make it little bit good looking. This is a very ugly formula. It is scaring me, so I don't want to be scared with it. So I will make it little bit good looking. So n minus r plus 1. Now what I will do is, like this 8 into 7 into 6 into 5 into 4. Ahead, if I do here multiplied by 3 into 2 into 1 and divided by 3 into 2 into 1. So will that make a difference? No, so that won't make any difference. So the same thing I will be doing here is I can write it in a general, in a good looking format as 87654. And when I complete that number 3 to 1, I can write it as using a symbol 8 factorial. And bottom it will be 3 to 1, it will be 3 factorial. This is little bit good looking, little bit less scary. So here the same approach I will use. N into n minus 1, n minus 2, we have stopped at this integer. What is the previous integer? So this, the previous integer, we have to subtract 1. We have to subtract 1 means what? N minus r. What is the more previous integer? The previous integer is n minus r minus 1. What is the again the previous integer? N minus r minus 2. Till where do we have to go? We have to go up to 3 into 2 into 1. So all those, if I'm multiplying it by this, then I also have to divide it by this. N minus r, n minus r minus 1, n minus r minus 2, so on and so on up to 3 into 2 into 1. So what does the numerator becomes? The numerator becomes n factorial, everybody. And what is the denominator? The denominator is, from starting from n minus r, we are going up to 1. The denominator is n minus r, its factorial. Now this is a compressed notation, a good looking notation, little bit less scary. Okay, got it?
Yes,
So
sir.
today we have derived this formula, that n factorial upon n minus r factorial. So this is out of n distinct objects, number of ways of arranging r objects without repetition, where r is less than or equal to n and greater than or equal to 0, or for now take it strictly greater than 0. That equality part I will explain. Okay, how to arrange 0 objects. It does not mean. Okay. So this question, it has a standard notation that out of n distinct objects, number of ways of arranging are less than n objects. So r objects without repetition, whatever will be the answer, it was decided that we will just simply call the symbol as npr. Npr means only the whatever is written in the superscript. Superscript is the total number of objects, and whatever is written in the subscript, that is the positions that you are taking. Okay, this is the meaning of this permutations, p for permutations. So it is read as npr only. So out of the superscript number of objects, subscript number of objects are taken without repetition, and what is the total number of permutations. So this symbol, the answer was found out to be equal to n factorial upon n minus r factorial. Got it?
Yes, sir.
Yes.
Okay, so I will just rub this part.
Yes, sir.
Now what about that 0? I've in the original part I've written r can be equal to 0 also. So does that makes any sense? Yes, it perfectly makes sense. R can be equal to 0 also. R can be equal to 0 also. What if R is equals to 0? Okay, so this is one of what if R is equals to 0. So you can say that, let's say, if I tell you out of 5 distinct objects, in how many ways can you arrange one object? In how many ways can you arrange one object? Question number star questions. Before star questions, 5 questions we have solved, no? Then 2 star questions we solved. Okay, so question number 6 now I'll give you. Question number 6. Number of ways of arranging one object out of 5 distinct objects without repetition. Is equals to how much? Shreya, you have written, sir, can you scroll up a bit? You have to copy this question or what? For
No,
this?
sir, that was before, sir. I'm good with it now.
Okay, okay, fine. Answer this quickly. Number of ways of arranging one object out of 5 distinct objects without repetition. Quickly. Very easy it should be. Yes, Janvi, correct. Puviyantam, correct. Okay. Shreya, correct. Puvi, try to calculate that value. It should be very easy. Try to calculate that value, Puvi. Shreya, correct. Pujita, how can you go in power, Pujita? No need of power. Your answer is correct, but that power notation not needed. Afrin, wrong. Puvi, yes, correct. Puvi. Afrin, wrong. Kartikeya, correct. Yash, what happened? Dev, right. Yash, not getting.
Yes,
Sir, I'm also not getting this one.
So number of ways of arranging one object out of 5 distinct objects. So 5 distinct objects means this is the same question. So here n is equals to 5. R is equals to 1. All objects are that we have to take note whether there are conditions are fulfilled. The red conditions, the conditions that are marked in red, whether they have been fulfilled. Those things you have to take note of. I have given distinct objects. Yes, sir. Okay, that is fulfilled. Without repetition, I'm telling, okay, sir, that is also fulfilled. Yes, fine. Number of ways of arranging one object out of 5 distinct. So here the total number of objects is n. The number of arrangements that pick up whether we have to do is r equal to 1. So this is just 5p1. Do you get it? 5p1. So this will be equal to what? 5 factorial divided by 5 minus 1, its factorial. So that will be equal to 5 factorial upon 4 factorial. So do we have to calculate 5 factorial completely, 4 factorial completely, and then divide? No, no need to bother. I can directly write the numerator as 5 outside, 4 factorial combined, and the division is by 4 factorial. I will cancel it. This division cancellation we have seen yesterday. Please do not ask. 5 factorial, I've written a 5 into 4 factorial, so 5 is the answer. Got it, everybody? Afrin, whether this cancellation is clear? Yesterday we were getting confused here.
Yes, it is clear, sir.
51. Okay, but whether this formula was really needed, okay, this explanation I gave you using the formula, but whether this formula was really whether it was a desperate need for the formula, no. Okay, simple logic. Formula bana kahan se tha? Means how you arrived at the formula? Using the logics only you derive the formula, na? So using the same logic, if you do, you have to just pick up one arrangement. You have to just arrange at the one place. You have 5 distinct objects. You picked up any one arrangement. If you picked up any one object, and how many ways you can arrange? You can arrange in one way. You can arrange in one way only. You picked up second object, and how many way you can arrange? You can arrange in one way only. You picked up third object, in how many way you can arrange? You can arrange in one way only. So one by one you're picking up, and one by one you're placing it. So 5 arrangements. That's it. Got it?
Yes, sir.
In how many ways can you fill up 5 seats in a hall out of 8 chief guests? Think whether this question is actually a question, is actually an application of the NPR problem. First, convince yourself that. Don't think that, sir, right now we are dealing with NPR. So whatever question sir is giving, it will be the formula of NPR only will be used. Be honest to yourself, convince yourself that whether or not it is a question of NPR, whether that formula will be used. Afrin, how is 5 into 4 into 3 into 2 into 1 can be equal to 5? 5 into 4 into 3 into 2 into 1 is 120. No? 5 into 4, 20. 20 into 3, 60. 60
Okay, sir.
into
Like, sir, I said that the number of digits are 5, sir. So, like 5 to 1, it is only 5. So, in that manner, I said, sir.
Shreya, Rahul, no, you no need to use combinations here. The formula for combination will be derived from this permutation formula, NPR. That is the next stage. The formula for combination will be derived from this formula without using the combination. And that for derivation of that formula also, again, I will take help of the unitary method only, Shreya. Life is very easy with unitary method. Okay. If you're stuck with the question, this rule applies for everyone. Means this is the always. If you're able to answer it. If you're stuck with the question, write EXP in the chat box so that I can understand that how many of you have given up. Okay, so I have got replied from Puvi, sir, explain. Janvi has replied correctly. Yes, very good, Janvi. Yash has given, sir, explain. Okay. Dev, correct. Kartikeya, you can do with formula, but you should be able to convince yourself that that formula is applicable. Okay, so I will give you the answer that formula is applicable over here. N is equals to 8 and R is equals to 5. So 8 factorial upon 8 minus 5, that is 3 factorial. 8 factorial upon 3 factorial is the answer. Shreya, now you have given that answer 6720. I don't know what that value is. If it is 8 factorial upon 3 factorial, then it is correct. But otherwise, I don't know what is that value. 6. Okay. Don't bother calculating it. In your paper, I'm giving you this guarantee that 6720 will not be given. Answers, your options will be given in this format only, 8 factorial upon 3 factorial. I guarantee you this thing. You can see, you can refer previous year question papers also. Okay. So how many ways can you fill up 5 seats in a hall out of 8 chief guests? So 5 seats are there. 1, 2, 3, 4, 5. And I have 8 chief guests. Obviously, 8 chief guests are all distinct. There is no cloning process up till now. So all chief guests are different. So 8 different objects, and I have to fill up 5 places out of them. So if I have to fill up out of many number of objects, I'm picking up a few and filling it up. So isn't it the question of simple of NPR only? N is equals to 8 distinct objects. R is equals to 5 positions. And sir, here you have not mentioned the condition of repetition without repetition. This is a practical life example. So this is an obvious common sense that here repetition cannot occur. If sir is sitting, if let's say Yash is sitting over here, Yash is the chief guest, is sitting over here. Can he simultaneously sit at this place? Not possible. So this is a common sense that here repetition is not allowed. Okay. So this you have to realize that here distinct objects are there. If without repetition scenario is given, and out of 8, 5 guests have to be filled up. So this is a NPR problem. So yes, sir, if NPR is, we have to use NPR, we directly have the formula, or directly approach you can use. So this is 8, 7, 6, 5, 4. 8 choices, 7 choices, 6 choices, 5 choices, 4 choices. Either that way you write, or this way you write. 8 factorial upon 8 minus 5, that is 3 factorial. Either way you get the same result, because this formula was derived from this result, 8 into 7 plus 6 into 5. Okay. Now, coming to our original question, I have to explain you the 0 factorial result. What if R equal to 0? So out of this 5 objects, out of 5 distinct objects, number of ways in arranging one object. Number of ways in which you can arrange one object. What is the answer? Number of ways you can arrange one object is, let's say, 5. Number of ways in which 0 objects can be arranged. Okay, so that part 0 factorial is equal to 1, that we will see in combination. Okay, that for that I will require the formula for combination. Here, let's say, here right now we'll skip it for today. In combination, I will tell you 0 factorial. 0 factorial is defined to be equal to 1. 0 factorial, we take it to be equal to 1, and this is the definition. So why it is defined to be equal to 1? This is a good question. Why it is defined equal to 1? 0 factorial, we could have defined 0 also, sir. Or if you are not convinced with 0, we could have defined it as anything. Why 1? 10, 100, 1000, 50, anything. So this reason I will give you why the 0 factorial is given to defined to be equal to 1. There is a not a proper means a logic. Why means logic means there is, it makes sense to define it as 1. Means ऐसा नहीं होता है कि I like to 1, 1 is my favorite number, so I defined it. There is a purpose behind that definition. That purpose I will give you when we will deal with combination. And when I give you this question, in how many ways can you fill up 5 seats out of 8 chief guests? Shreya asked me the doubt that, sir, whether we have to solve it using combination. What was the logic behind that doubt? That doubt was a very good question actually. I'm telling this to other students. Okay, what Shreya was probably thinking. Let's see, out of this 8 means now I'm giving you the hint for the next class. Okay, Right now, I'm giving you the hint for the next class. Next class, we will start with combinations. So what Shreya's doubt was, so do we have to use this formula or do we have to use the combination approach? So combination approach कैसे क्या आया इसमें? Combination approach was, so see, out of 8 chief guests, I will pick up first 5. Any 5 I will pick up out of my choice. So once I picked up that team of 5 chief guests, then I will arrange them. But then I will be done with that team. Then I will pick up another team of 5 chief guests, and I will arrange them. Their arrangement will be same. Okay. So if first team I picked up, and if I arrange them in, let's say 100 arrangements are possible, then second team I picked up, second team of chief guests I picked up, for them also 100 arrangements will be there. So right now total 200 arrangements are there. Third team I picked up, they will be arranged in 100 ways, so 300 arrangements, so on and so on and so on. So what is the total number of teams that I can pick up? So now the question comes, out of 8 different arrangements, what is the total number of, out of 8 chief guests, in how many ways can you pick up a team of, how many different teams of 5 chief guests are possible? So what can you use? Sir, if you give me the answer for how many number of teams, I can give you the number of arrangements. This question. Okay, I'm giving you the hint for the next class. If you give me the answer for the number of teams, so you give me the ready-made answer, let's say for example, 12 teams are possible. Example, hypothetically, okay, 12 teams are possible. So 12 teams multiplied by whatever the number of arrangements for one team is there. 12 teams multiplied by number of arrangements for one team. Let's say for one team, there are 100 arrangements. So 12 teams multiplied by number of arrangements for one team is equal to total arrangements of 5 chief guests out of 8 chief guests. Do everyone agree with me? This result that I have written. This is hypothetical. Okay, if there are 12 teams are there, number of teams multiplied by number of arrangements for one. Okay, let me write number of teams here. Number of teams multiplied by number of arrangements for one team, that will be total number of arrangements for 5 chief guests out of 8. If anybody is having doubt for this result, raise your hand, otherwise I will proceed. So sir, if you can give me the answer for number of teams, I can find the total number of arrangements, but I do not know this. Okay, fine. Today we have calculated total number of arrangements. Don't think of proceeding in this way, because this is a question mark. This we do not know. We will proceed in this way because this is known to us, and tomorrow we will calculate this number of arrangements, number of teams equal to how much. Out of 8 chief guests, how many ways can you select a team of 5 members, 5 chief guests? 15 member squad is there of cricket. In how many ways can you select a playing 11 team? Got it?
Yes, sir.
So
Yes.
think for a while. You know this answer, the right side. Whether you know this result, think. If you know this result, the division gives you the number of teams, the combination approach tomorrow. So read the combination formula, but tomorrow or the next week, whatever we will discuss we will solve the number of questions over this permutations only. Permutations questions only we will solve, and then when we are done with the formula for combination, I will explain you the logic behind 0 factorial equal to 1, and then we'll do the combined questions of combination as well as permutations. Okay. And in this number of digits, the digits today that I have given you, I have avoided the digit 0. That 0 questions also we will deal with. Okay. So I hope everything is clear. Have a nice day, everybody.